All right, welcome back. We're going to finish out our systems of equations lecture, and we're going to cover two new methods. The first one that we're going to sort of formalize, we kind of did a little bit last time, is substitution. We're going to use the substitution method. I have a graphical representation here. I didn't even label the axes. I have a graphical representation here just to remind us what we're trying to do. We're trying to figure out where those two linear relationships intersect. But we're going to forget about the visual now, and we're just going to focus on the algebraic approach. So you've got y is equal to negative 3x plus 1, and the substitution approach has us take whatever y is equal to and plug it in to the y. Then we solve for x. So if we do that, we'll get negative 2x plus 2 times negative 3x plus 1 equal to 2. All right, let me distribute my 2 in, and I'll be left with negative 2x plus negative 6x plus 2 is equal to 2. Let me combine these like terms real quick, and I'll combine the negative 2x plus negative 6x, or negative 2x minus 6x into getting negative 8x. And those disappear. That becomes, those disappear as well. So this becomes negative 8x is equal to 0. And if you divide both sides by negative 8, 0 divided by negative 8 is still 0. So it looks like our x value is going to be 0. Let's plug it in now. Doesn't matter which equation we plug it in for. We can plug it in for the top one or the bottom one, and it'll get us the same thing. You plug in 0 for x here, you get 2. Let me just show you guys so that you guys don't have to just trust me. You can see my proof of it, my informal proof. I got negative 2 times x, which is 0, plus 2y equals 2. That's this blue one. Now the red one, that's going to be y equals negative 3 times 0 plus 1. All right, what is 0 times negative 2? It's just 0, so that's going to become 2y equals 2. Divide both sides by 2. Y equals 1. All right, this one should equal 1 too because they have to be the same thing. Remember, both of those lines are intersecting at the exact same point. They share the exact same y and x value. So if they share this x value, then they should share the y value. This linear relationship should also equal 1. Let's see. That's going to become y equals 3 times, or negative 3 times 0 is 0 plus 1. 0 plus 1, or y equals 1. In both cases, we've got x equals 0, y equals 1. So our answer is going to be 0, 1. That's where those two lines intersect. That was also an example of the substitution method. And now let's get a little weird. We are going to use a different method to solve that set of equations over there. Almost tripped on my charger. Now to solve this, neither of these two linear relationships are in slope-intercept form. Neither of them has x equals or y equals, so we can't just automatically substitute. We could solve, we could manipulate this to get y by itself or to get x by itself, but instead, let's use a different method that we can use from linear algebra. But let me show you what it is. It's called the elimination method. the elimination method, and we are going to eliminate one of these variables, and we do so by doing this. We'll multiply one of these equations. In this case, you'll see why in a second. In this case, I'm going to choose this one. And I'm going to choose that one to be multiplied by 2. Then I'm going to add these two linear relationships. I'm going to add the two of them together. So that'll give me negative 6x plus 4y equals 10. I got to distribute it to each individual part. And then on the bottom, I'm going to have the same thing as I had before. 6x plus 5y equals 13. Okay. Next up, I add them together. Those will cancel out. That'll be 0x, or just 0. Those will be 9y is equal to 23. So y is equal to 23 over 9. We found out one of our values. We now got to plug it back in to get our x. Let's take this y. Let's see. I guess neither of them will look particularly easier than the other. So let's just plug it into one of these two random ones. Remember, I already showed you guys that it doesn't matter which one you plug it in for. It'll get you the same thing. But I'm going to plug it into that one and see what we get. All right. So I plug in 23 ninths for y into 6x plus 5y equals 13. But remember, we're not doing y. We're doing 23 ninths. Okay, that's going to leave me with 6x plus 115. Is that right? Yeah, 115 over 9 equal to 13. Okay, I'm going to have to subtract. Give myself some space here. Subtract 115 over 9. Yes, this is a particularly complicated example. You won't normally get results in the fractions like this. Or rather, I won't give you problems like this. I'll normally give you problems with whole numbers. But you're going to have, subtracting this from both sides. Hey, this is just good fraction, addition, and subtraction review, okay? We're going to subtract that from both sides. On this side, it'll cancel out. So on this side, I'll be left with 6x plus 0 is equal to 13 over 1 minus 115 over 9. Well, looks like I'm going to have to multiply the numerator and the denominator up here by 9. 9 over 9 is 1. So I'm allowed to do that. It won't change the value. Let me show you what I mean up here. Go in a different color. Keep it interesting. So I'm going to have 6x is equal to 9 over 9 times 13 over 1 minus 115 over 9. So that's going to be 9 times 13. 130 minus 13 is going to be 2017. So 117 over 9 minus 115 over 9. So 6x is going to be 2 over 9. Divide both sides by 6, which is the same thing as saying, those will cancel out, which is the same thing as saying multiply by the reciprocal, or this is 6 over 1, so 1 over 6. So x is going to equal 2 over 54 Or for those of you guys who can see the simplification, 54 is really 27 times 2. So those will cancel out, and we'll just be left with 1 over 27 for our x. We have our y, we have our x, so we have our answer. Our x is 1/27. Our y is 23/9. And that is the point of intersection. All right. Please feel free to look up other systems of equations videos, particularly this section. There are so many talented YouTube math people who cover this stuff in less time and with more expertise than I was able to. So take a look, but feel free to Google someone else. And that concludes systems of equations. Bye. Cheers.